Assalamu alaikum everyone. In today's lecture we will learn about Hilbert-Schmidt theorem with applications method for symmetrical kernels. We know that the question given is y of x is equal to 1 plus lambda integral of 0 to pi cos x plus t y of t dt. Comparing it with general equation, we get the values of f of x, lambda and kx of t. Now, for determining, first we have to, in Hilbert-Smith theorem, first we have to determine eigenvalues and corresponding normalized eigenfunctions. For this we have to calculate c1 and c2, and c1 in terms of t and c2 in terms of t also. So we split the equation, we use formula cos alpha plus beta in this equation, in equation 1, and split and get c1 and c2 in terms of t. Now replace replace c1 and c2, put c1 and c2 in equation 1, and replace x with t. Now c1 is equal to 0 to pi cos t y of t dt. Put y of t in equation 2, and in this way we can solve c1. By solving c1 we get first equation, which is 2a. Now after that we have to find c2. Put y of t in c2, then we get second equation, which is 3a. Now from equation 2a and 3a we have non-trivial solutions, only if when d of lambda is equal to 0. D of lambda, putting values by using 2a and 3a, we put values 2 minus lambda by 0 0 2 plus lambda pi, and after multiplying by using property of determinant, we can get eigenvalues, which is lambda 1 and lambda 2, which is lambda 1 is equal to minus 2 by pi and lambda 2 is equal to minus 2. um, Lambda 1 is equal to 2 by pi and lambda 2 is equal to minus 2 by pi. And then first we can find the eigenfunction corresponding to lambda 1, which is 2 by pi. Lambda 1 is equal to 2 by pi, and we obtain, putting in equation 2 and 3, we know that equation 2 is c1 is equal to 0 to pi cos t y of t dt, and c2 is um 0 to pi sin t y of t dt. After putting lambda 1 is equal to 2 pi in equation 2 and 3, we obtain these two equations, and in these two equations we will see that c2 is equal to 0 and c1 is arbitrary, because c1 is 0 in both equations, so we can take c1 is arbitrary. Put in equation put this value in equation y of x is equal to 1a lambda c1 cos x minus lambda 2 c2 sin x, and we get y1 is equal to 2 by pi c1 cos x. Now we can take setting 2 by pi c1 is equal to 1, we may take y1 of x is equal to cos x. Now we all know that the corresponding normalized eigenfunction formula for this is y1 of x is equal to y1 of x divided by integral of 0 to pi y1 of x ka square dx in whole square root. And we can say, put values of y1 of x, which is cos x, we find here cos square x, then take square, we get cos square x is equal to, we know that by using trigonometric identities, cos square x is equal to 1 plus cos 2x divided by 2. Putting this value in formula of phi 1 of x, we get this, and solve this integral. After solving this integral, we get this answer: 2 by pi 1 by 2 cos x की power 1 by 2. Determination of, now we can determine eigenfunctions corresponding to value lambda 2 is equal to minus 2 by pi. Minus 2 by putting minus 2 by pi into equation 2 and 3, we also again obtain these two equations. Then after comparing these two equations, we see that c1 is 0 in c1 c2 is 0 in both equations. C2 is 0 in both equations. C1 is 0 and c2, so we can take c2 is 0 in both equations, so we can take c2 is arbitrary and c1 is equal to 0. Then putting this value in, putting c1 and c2 in 1a, we get y2 of x, which is equal to minus 2 by y multiply c2 sin x. So setting again, by using again the same method is applied. 2 by pi multiply c by 2 is equal to 1. We can take y2 of x, which is equal to sin of x. The corresponding normalized eigenfunction for y2 of x, we know that formula is y2 for y phi 1 of x, we know that, and phi 2 of x is also this, but only remaining y1 of x by y with y2 of x. Y1, putting the values of y2 of x in this equation, and after scaling it, we again use trigonometric identity, sin square x, which is equal to 1 minus cos formula of sin square x, 1 minus cos 2x divided by 2. After putting this, solve the integral, and we get this answer. And then now we have to calculate f1. F1 is equal to integral of 0 to pi f of x phi 1 of x. After putting phi 1 of x and f of x in equation, in this equation we get f1, and after solving this integral we get f1 is equal to 0. Now, now for finding f2, we know that the formula is again 0 to pi f of x phi 2 of x. For f1, from here we use phi 1 of x, and for f2 we use phi 2 of x. F of 2 is equal to, f2 is equal to, putting phi 2 of x in equation, we get f2 is equal to this. Now three cases arises. Case 1, in which unique solution exists when lambda is equal to lambda 1 and lambda is not equal to lambda 1 and lambda is not equal to lambda 2, then unique solution will possess. And we know that in general form, the equation of general solution, the in unique solution, the equation of general solution is y of x is equal to f of x plus lambda summation m is equal to 1 to 2 f of fm lambda m minus lambda phi m of x. Putting this, we know that m is equal to 1 and 2. F1 we calculated it, and phi 1 of x we know that, f2 phi 2 of x we calculate all these values. Now putting all these values in this formula, we get y of x, which is this. Now case 2, which is no solution, and when it happens when lambda is equal to lambda 2 and f2 is not equal to 0. In infinite many solutions, when lambda is equal to lambda 1 and f1 is equal to 0, then we get infinitely many solution. And the difference between infinitely many solutions and no solution is that, here f1 is equal to 0 and here the corresponding value and is equal to lambda, but f2 is not equal to 0, so we get no solution. After, and then lambda is equal to lambda 1, which is equal to 2 by pi, since f1 is equal to 0, so there exist infinite many solutions. And for infinitely many solutions, the general equation is y of x is equal to f of x plus a phi 1 of x plus lambda 2 minus 1 lambda, because f1 is 0, so we cannot take the f1 of x, because all these term, after putting in formula, after putting in this formula, f1, the whole f1 value is 0, so we only take f2 of x. And putting all these value, putting value of phi 1 of x, phi 2 of x, f2 in this in this formula, we get this form. And we can take c. After solving it, we can take, we know that c is equal to 4 under root 2 over pi, which is an arbitrary constant. So we can take all these values, which is equal to c. Now I will give you some exercise questions along with answer to solve this. After in solving this, if you face any difficulty, you can ask me and in comment section, and I can answer your problem.